Welcome back. In this video, we're going to try to find the limit of u sub n, which is defined by this integral between 0 and 1/2 of 1 over the square root of 1 minus x to the power n. So here we want to find the limit as n goes to infinity. How can we do this? Note here that we are treating x in this case as a constant when we integrate, and therefore this integral will depend on n. So we can treat u sub n as a sequence. Okay, and we're gonna base our reasoning on the squeeze theorem. We'll see how we can use that to find this limit. Okay, we have two key ideas. First is that x is between 0 and 1/2. Second, this integral, this function is always positive, okay, in this interval. So based on these ideas, we're gonna find our limit. Okay, so first note that x is between 0 and 1/2. Okay, so next we're gonna raise everything to the power n. Nothing is gonna change in this operation. When we do raise everything to the power n, nothing is gonna change since everything is positive. Okay, next we're gonna multiply by -1. So here, when we multiply by -1, we're gonna have this integral, or this value will be between -1 to the power n and 0. Next we add 1, so we add 1, so we're gonna have, nothing is gonna change again, and we're gonna have 1 minus x to the power n will be between 1 minus 1/2 to the power n and 1. Next, we know that the square root conserves the order. So everything is positive here. This 1/2 to the power n can never exceed 1. So this is positive, and the 1 is positive. Therefore, we can take the square root of everything. Okay? So taking the square root, we're going to have the square root of 1 minus 1/2 to the power n. And here we're going to have the square root of 1 minus x to the power n less than 1. Okay? Now we flip everything. Everything is positive. We flip, or we invert our values. Everything is going to change, except that this function, when we flip it, it's going to stay in the middle. So we have 1 over the square root of 1 minus x to the power n is less than 1 over the square root of 1 minus 1/2 to the power n, and it's bigger than 1. Okay, so this result is extremely important for us now to be able to integrate. Okay, and we know that the integral, given that two functions in this order, when we pass to the integral, nothing is going to change. Okay, so we do it here. So we know that we are integrating between 0 and 1/2. Okay, so once we do that, we're going to get in the middle. Here we're going to have our u sub n. Okay, so once we integrate between 0 and 1/2, we're going to have our integral. So therefore, I'm going to write it down here. So when I integrate this quantity between 0 and 1/2, I'm going to have my original sequence here. Okay, on the left side, I'm going to have the integral between 0 and 1/2 of 1 dx. And on the right side, I'm going to have, this is just a constant. So I'm going to keep it outside, and I'm going to integrate between 0 and 1/2 dx. Okay, so once we do that, okay, this one is just 1/2. So here I have 1/2. This is my sequence inside, and here I'm going to have 1/2 1 over the square root of 1 minus 1/2 to the power n. Okay, now I need to find the limit. So now I'm in the conditions of applying the squeeze theorem. Okay, so I have this constant sequence and this sequence here. Okay, if I can find, or if or if I can show that this limit here is 1, that means my sequence has 1/2 as a limit. Okay, so here when I take the limit, so taking the limit, okay, so taking the limit of all the sides, so taking the limits, okay, so here this is 1/2, okay, this is 1/2, and this is the limit as n goes to infinity. But this one here, this limit here, so the square root is a continuous function. I can enter the limit inside, and once I do that, I have this limit here as n goes to infinity. So this is just 1. Therefore, I have 1/2 as well here. So therefore, I have exactly 1/2 and exactly 1/2, and this means that my limit, the limit of my sequence is 1/2. Okay, so now we proved the result using the squeeze theorem and just the order in R using algebra. Note that we have used algebra, and we use algebra all the time when dealing with this kind of questions. Okay, note here that we can use other techniques. If we can use some other techniques without using the squeeze theorem, but that means finding a primitive of this integral. We can do that, but the squeeze theorem is very nice and beautiful, and it will lead us directly to the result as we have seen here. Okay, so this is all I can say for this this limit. If you see any errors or mistakes, please let me know so I can correct it. Thank you very much. Please like and share. Okay, thank you very much. Have a great day.